Hello, everyone, and thank you for joining today's Pexata webcast. Before we get started, I'd like to go over a few items so you know how to participate in today's event. When you join today's webinar, you've selected to join by phone call or computer audio. If for any reason you'd like to change your selection, you can do so by accessing your audio pane in your GoToWebinar control panel. You'll also have the opportunity to submit text questions to today's presenters by typing your question into the question pane of your control panel. You may send in your questions at any time. We will collect these and address them during a Q&A session at the end of today's presentation. And I'd like to introduce Nanshad Bardaliwala, Chief Product Officer and co-founder of Pexata.
Thank you very much, Andrew, and good morning, good afternoon, good evening, whatever time zone you may be in. It's a pleasure to have you on today's webinar, and I look forward to getting started and talking about how we can uncover some business value from your data lake. So let's dive right in. So one of the questions that I'd like everyone to ask themselves is, how can we help business people in the organization, and that includes all of you, to be able to turn the raw data that we're getting constantly from all the different data sources in the enterprise into information, trustworthy information, instantaneously? Well, the first part of that statement means that we have to figure out what's the difference between raw data and information. And it's a really interesting question because one person's raw data is another person's information. We are all very used to being in an enterprise context, pulling data from CRM systems, ERP systems, and the like, and we've developed a lot of really strong practices around taking that data and turning it into information. But what happens when we start adding machine data or social media data or any of a variety of new data sources in formats like JSON and XML, and we want to turn that into information? Well, for us, the difference between raw data and information is how do we take raw data and make it complete so that you have the full set of information necessary to make a decision? How do you make it clean so that the syntax is standardized and the semantics are normalized across all of the data sets you're working with? How do you make it contextually relevant to the business problem that you need to solve at hand? That context often comes from third-party data sets that you use to enrich with your internal transactional data that can add a lot of business meaning to what you're working on. And finally, even if you do those first three things, if you can't consume the information, if you can't make it useful in a context that's in a BI tool or an analytic application or predictive model, then it's not very useful to you. So for us, raw data becomes information when it's complete, clean, contextual, and consumable. Now you may say to yourself, well, Nanshad, I've heard of all this before. In fact, we've been turning raw data into information for the last 30 or 40 years in our industry. And that is true. Many of you are probably very familiar and have in your organizations really strong tools like Informatica or Talend or IBM DataStage, and those tools were typically used to take transactional data from mainframes or from relational databases, and we would pour them into star schemas in our enterprise data warehouse. And some of you probably went through the battles of Kimball versus Inman, and that whole thing, and then finally we would design our analytic application metadata and create some reports on top of it using MicroStrategy or business objects. And there are some limitations to that approach that I think are worth considering. One is that this entire tool chain, especially in the data integration and information management side, really have been designed for IT professionals only. You are not putting your average business person in front of your Informatica toolkit unless you want them to start screaming. Number two is that you know that these solutions were built for a world where everything was batch. And so you design everything up front, you push all the data through one of these data pipelines, and at the end, you can see whether the data is actually what you were hoping to get out of it. Number three, another big challenge with the way we've done this is that all of these different tools, while they are excellent on their own, they actually have so many of them that it's impossible to figure out which tool to use for which use case. You can have one product for data quality in the cloud, another product for data quality on-premise, one master data management product for customer data, one master data management product for product data, and then you have 2 or 3 different ETL tools. And they're sold to you as a platform, but really they're a single offering only because they come on one DVD or come from one download site. So it's very, very difficult to use all of these disparate tools. They're also completely manual. You have to know, based on looking at the data, you have to use your human intuition to say, I need to put a join here, I need to put an aggregation here, I need to put a filter here. There's no assistance really. Most of these tools were designed for working with relational data. And if you built a tool 20 years ago, which is what many of the traditional tools are coming to in terms of their birth dates, it makes total sense to be able to work on relational data only. But now with JSON, XML, streams, it's much, much more difficult to work with systems where the relational model is built in to the inherent way that the solution works. And finally, another thing that makes working with the traditional tooling difficult is that these are scale-up on-premise deployment approaches. And a lot of our workloads today are spiky. They can be ephemeral. And so the folks in IT who are responsible for running these systems really don't like having to buy, a huge server when you're only using 20% of it for 99% of the time. So for these 6 reasons, we believe at Paxata that traditional information management approaches are outdated. Now, if our hypothesis is correct, then that would lead to the conclusion that today, in most organizations, in the folks who are on this webinar today, turning raw data into information is broken. The IT teams don't always understand the data at the level of detail that the business people do, but they really understand how to use the tooling, and they're very good at it. And on the other hand, the business folks can't really use the IT tools, and therefore they're frustrated because they can't get their work done. So there's a complete imbalance between folks who really know how to use the tools and are very technically competent, and the business folks who really know what they want to do with the data in a business context, but they can't use the IT tools. And so as a result, 80% of the work that we spend trying to do analytics, which really what we're trying to do is get information that helps us make good business decisions, 80% of the time for all of you is spent on the data preparation process. And it gets even more interesting because there has been, in the IT stack, multiple changes that have happened in different layers of the enterprise. If you look at the analytic apps, BI tools, and advanced analytics market, we have seen over the last 5 to 7 years that there's been a big shift from the centralized IT-managed tools, such as MicroStrategy, Business Objects, Cognos on the BI side, or SAP, OutlookSoft, and Oracle's Hyperion tools. We've seen this big shift from there to a new set of tools like Qlik and Tableau or Anaplan, where they are much more business-centric. They're much more designed to be used by a new end-user community. They're very flexible. They're very agile. And that has certainly put a lot of pressure on the market for vendors to react. At the same time, as self-service BI has really taken off, you've also seen that the entire data management infrastructure, and the focus of today's webinar is how we're moving from these relational technologies to more of the quote-unquote data lake world. And the question that really begs itself is, well, what does that mean for your information management layer? If we're moving to a world that's self-service from an analytics perspective, if we're moving to a world where data management is moving from not just relational, but relational plus the data lake model, what do we need to think about differently from an information management perspective? So let's dive into that. If you look at the data lake architecture, there's a lot of good writing on this topic from folks like Gartner and Forrester and other very good third-party analysts. In this case, I captured this from Mark Madsen, who is a fantastic analyst who is an independent. If we look at the data lake architecture, it is quite different from what we have been used to in the enterprise for the last 25 years. This is an architecture that deals with change very easily, and it deals with it at scale. It does not require you to model data up front. one of the big limitations of the traditional approach is that we have to model everything in advance, which means that we have to know what questions we're going to ask before we even put any of the data into the system. We also see that the data lake environment requires that you have flexibility in terms of the formats or structure of data. We have many customers who are actually not only storing textual-like data in a variety of formats, but they're actually storing video and audio and using really interesting data mining algorithms on top of that. The data lake architecture also allows you to think about a range of different data latencies. In some cases, you're going to work with massive bulk type data processing, where people are, running a MapReduce job on a petabyte of data, or you might be working with streaming or microbatch type use cases. But the beauty of the architecture is that in a single architecture, it can accommodate this flexibility of formats, flexibility of modeling techniques, flexibility of data latencies. So what we are typically seeing customers do is that with this data lake architecture, within the data lake, people are setting up different zones. A raw zone where you're taking the absolute raw data from the source and landing it in the data lake. An enhanced zone where you have some cleaned data that's standardized in certain ways. Integrated data where you're using technologies like Paxata and others to model the data, create sort of transitive data marts and that kind of thing. And then you can also store within the same data lake all the derived data, the output answer sets that come from all this analytic processing. So the characteristics of the data lake, the flexibility, the layering of the architecture, the multiple formats, mean that we have to rethink how information management has to work. And then if we look at self-service BI, the exact same questions need to be asked. If we look at the spectrum of the type of people who are working with the self-service BI solutions, solutions like Tableau and Qlik and Spotfire, what you'll see is that there is a spectrum. In this case, I'm using some research from Gartner to show how we can go from centralized and controlled static reporting, which is what most of our industry has been for a good part of the last couple of decades, to completely decentralized and autonomous, which is basically me and the Excel spreadsheet sitting on my desktop. And where self-service BI fits in is kind of this blend between data discovery, ad hoc query and OLAP, and interactive reporting. And what we are seeing in the market is that many of our customers are starting to roll out a multi-layered architecture where, again, it's not that relational technology is going away and the data lake is replacing it. It's not that the traditional reporting stack like MicroStrategy and Business Object is going away and Tableau is replacing it. But these new architectural paradigms and new capabilities are being layered into a much richer set of capabilities where you have the ability to do very little modeling in advance. The end users can visualize their data on the fly, and you don't have to do a lot of the pre-setup work that we would do in the traditional enterprise reporting world. So the result is that the end users are able to get productive really, really quickly. So when we saw these trends at Paxata, when we started the company almost 5 years ago, actually it's March, so it is 5 years ago, what we noticed is that a lot of the technology that was in the market was really focused at these left two buckets or categories of people. You have the data scientists. These are people who are working primarily with open source tools like R or Python or Scala and working with technologies like Spark. And coding by hand, they're extremely valuable to an organization, but there are not that many of them, and it's very, very hard to scale this function. If you go to the developers, frankly, there have been a number of excellent tools in the market that really suit the developer community. I mean, tools like Informatica and Talend do a great job of serving that developer community. But in a world that is moving towards self-service, in a world that is moving towards the data lake type architecture where flexibility and multiple persistence formats becomes important, how do we empower the business analyst community? And these are folks who we define at Paxata as individuals who have the ability to use Excel. They know what a VLOOKUP is. They know how to create a pivot table. So they have, a bit more advanced skills than the average Excel user, but they are already doing this type of data preparation work on a regular basis in Excel today, but Excel is not a great tool for it. And then, of course, there's the broader market of sort of the business users and information workers who are not the current focus of the market in terms of the types of things that we're discussing on today's call. So what we thought about in terms of trying to solve this problem was to imagine that we could build a system that was self-service, that was designed for the data lake environment, where we could take data and turn it into information with clicks and not code in just a couple of minutes and not months. And so we would try to weave together the ability to gather data and explore it and join it and clean it all into one integrated interactive suite and be able to publish that data to any destination or data source that people wanted to be able to work on, and to do this on top of any number of data lake environments that people are working with today, whether they be on-premise systems like Cloudera's or Hortonworks or MapR's or IBM Big Insights implementations, or in the cloud with Amazon S3 and EMR, or Microsoft's technology with HD Insight. So when you look at the paradigm change that has happened over the last couple of years, and this is a really important thing to understand, is that what we are now seeing, and what many of you are probably seeing in your own environments, is that the traditional stack needs to keep operating. Nobody's tearing it down because there are still very valuable reporting and other artifacts that are being created from that traditional stack. But in parallel, you now have on the right side all the raw data, and that raw data is being landed into these various data lake environments, which have the various zones that we talked about: the raw zone, the lightly enhanced zone, the derived data zone. And then from the data lake, people are putting a new set of technologies on top of the data lake, like Paxata, which are designed to be schema-free, which are designed to scale out the same way the data lake does, which are designed to work in this self-service environment, which can then feed tools like Tableau or R or any of the self-service tools. And the cool thing about it is that you can still leverage all of the artifacts from your traditional stack in the new stack as well. So there is by no means a notion for us that we only pull data from the data lake, because people are using technologies like Paxata to also pull from their traditional relational sources, pulling from file-based formats, pulling from FTP sites. Those haven't gone away. Or pulling from the enterprise data warehouses, which are often a very valuable source of information to then be able to do adaptive information management. So the point here is that there are two stacks developing. They are going to work hand in hand and in tandem for a very long time. And what we see is that the paradigm is shifting from information management being a pre-modeling layer that sits between your transactional systems and an enterprise data warehouse to this new paradigm where data is being ingested raw in the data lake. It's being iterated on and sculpted using this new class of tools like Paxata, along with pulling data from the enterprise data warehouse and the traditional systems, and then, of course, pushing it out and allowing end users to be able to serve that information to a variety of different tools that they have in the enterprise. So if that's the case, what type of architecture and what type of capabilities would you need to have in order to function well on top of the data lake environment? We at Paxata look at four different things. We think that the solution needs to be truly built for the analysts, for that same self-service person who's working with Tableau or Qlik. But there still needs to be a very important aspect of IT governance. We do not avoid IT in any way. We think they're a crucial partner in the whole process. Number two, we have to have an enterprise-class unified set of capabilities that allow people to do all of their work in one environment without having to jump from place to place. Number three, we need to work in a world just like the data lake, which is schema optional, where I can impose schema on demand when I need it in order to handle the analytic use cases that I have, and to even use very interesting algorithmic tools to be able to automate some of the ability to bring these various data sources together. And then finally, to be able to support the flexible deployment models that customers are working with today, whether that's deploying Spark on Yarn in your on-premise environment, whether it's running in AWS, as we happen to do with our multi-tenant cloud offering, and being able to burst up and burst down your capacity, depending on the workloads, in an environment that is truly multi-tenant from the ground up. So let's dig into each of these and understand them a little bit better. So the first is, how do we build for analysts but enable by IT? So as someone who was an analyst, probably feels like 100 years ago now, but when I was an analyst about 18 years ago, I was one of the people who you would find using Excel, copying and pasting data into a spreadsheet, using VLOOKUPs and pivot tables to massage my data into some kind of format that could be used for analytics. So what did I as an analyst expect, and what have we heard at Paxata from customers over and over again talking about analyst-type personas? Well, the first is they don't like script. Yes, you will find in any virtual or real bookstore those one or two people who love the Excel macro books, and I knew some of them, and maybe I'll confess I was one of them at one point in my life. But the truth is that the majority of the time, people just want point-and-click pre-baked functionality. I don't want to learn your new scripting language that you think is cool. I don't want to learn your new macro language. I just want to get my job done, so give me a point-and-click environment where I can just do what I need to do. I want it to be visual. Give me visual indications of what the data looks like. I want it to be interactive, even on really large volumes. I don't want to be told that, Microsoft Excel in this day and age of 2017 supports 1 million rows inside your desktop system. So if Microsoft Excel supports that, why should I settle for a system where I have to sample 500,000 rows for an enterprise class system in order to be able to do my work? If I'm an analyst and I'm working with data from the data lake, let me work with all the data. It might be 50 million rows. It might be 100 million rows. But I should be able to bring all that data in, profile it, join it on the fly, change its shape, etc., so I can take advantage of all the power of the information we have inside the data lake. So point and click, visual, interactive, very quick response time are very, very important aspects of what makes a solution attractive to your analysts. But at the same time, we do not want to be the wild, wild west of Excel. Most of you know that is a nightmare world to be in, and we haven't truly escaped it. But the way that we try to solve that problem is to say, look, we can, of course, apply the types of governance controls that you expect in any enterprise application in terms of each of your different permission profiles and that sort of thing. But the fact is, what we've learned in our many years being in the BI industry is that if you limit your end users too much, they immediately go back to Excel, and then you defeated the whole purpose or the major part of the value you were going to get from your system. So what we've tried to do is say, look, we are going to have a very flexible point-and-click, do what you need to do type of system for the analysts. However, we will not escape the need for IT to provide governance and scalability, because what we think you should be able to do is we want to be able to record every single step that you take inside of our solution. And not only does it record it, it's completely available in English language. I can see where I pull in the starting data set. I'm able to then go and see that I did a find and replace and a split, what columns I did them on. So visually indicate to people exactly what operations were taken inside the underlying system. In fact, not only do you want to store all that, you even want to track all the versions of the different data sets and the different transformations that are in the system. Be able to write annotations. So you can say, hey, Joe, just want to let you know that I cleaned up this data by scrubbing out all of the values from Q4 of 2016. Now you can go ahead and use it. And so even that human input that you want to be able to put in the system, you should be able to capture that in a way that is completely reproducible. So the key here for us is that if you're going to use a system like this that has this flexibility, allow me to create any snapshot in time by being able to roll back to a previous version of the data or roll back to the previous version of the transformations that I've done. So this is governed business flexibility, not the wild, wild west of Excel, which is really important to understand. Next is the notion of unification. Like many of you, whether you're an end user in your company or your administrator, we already have too many tools. When I sit here and try to figure out whether somebody's trying to text me or use Slack or use email, it's impossible for me to keep track of my communication. Well, that same problem exists in terms of how you get your data ready into information. So what we believe is that all of the core capabilities that you need in order to take raw data from the data lake and make it useful need to be in one solution. So I need to be able to go find that data inside of my data lake. I need to be able to explore it. I need to be able to go into the directory structure that somebody set up in HDFS or in Hive or S3 and see what does that data look like. I want to actually put my eyeballs on them and see what that data looks like. Once I bring that data in, I might want to profile that data. How many blanks are in this data? What are the various different values that are inside of this information? I might want to integrate and bring in other data. So, not only pulling in data from the data lake, which is very valuable, but hey, let me go pull in some of that relational data. Let me go pull in some of the data that's sitting in our file stores. As I said earlier, those aren't going away. So how am I able to go ahead and actually make that whole thing happen? Enriching. How do I actually look up additional values from third-party data? I might want to bring in information from Dun & Bradstreet or from Reuters and enrich it as part of the system. Being able to collaborate with other people, right? So how do we, one of the very cool things that Google Docs did is it allows you to actually see what multiple people are doing at the same time. And so we've actually implemented that kind of technology in Paxata where two people can actually look at the exact same browser environment and see exactly what people are doing inside of that. So that's also a really, really useful thing in a system like this. So the point is, put it all in one place. I don't want 50 different applications for doing this type of work. Number 3 is let's use smarts in order to be able to do this type of work. It's really, really interesting, but actually the whole genesis of Paxata came because we use algorithms to automate the process of telling you how to connect your data sets together. You don't have to open up 3 different database windows and figure out how you're going to join the data from your CRM system in Salesforce with your data from Marketo, or your data from your ERP system and your data from some other financial system. We can actually use really smart machine learning algorithms, and Paxata does this, to be able to automate the process. So if you have hundreds of thousands of different data sets inside of your data lake, you sure as heck don't want to figure out how you're going to bring those data sets together manually, especially if a system can do it for you. And then last is really about the architecture. How does this fit inside of your data lake environment? And does it fit naturally? Is it a good citizen inside of that environment? And so in the architecture that we've built, there is a UI layer along with a set of RESTful APIs, because we have a lot of customers that want to use Paxata in a programmatic fashion, and they can do that using the RESTful APIs. A middle tier that provides a lot of the different application services. But then, especially in the data lake context, it's really important to note that we run on top of Apache Spark. We were actually one of the first companies to do this in 2013. And on top of Spark, which is part of all the major Hadoop distributions, although it's also available as a standalone product as well, is we deploy our own technology which turns Paxata and turns Spark into a large-scale columnar interactive data preparation engine. So one of the things that's really compelling about the technology is that I can work with these very large volumes without having to suffer the difficulties of working in a sample-based environment and actually look at all the data to find the outliers, etc., instead of just working with a trivial amount that even Microsoft Excel could do. So you need to be able to deploy this architecture directly on top of your data lake environment. So if you already have Yarn, if you already have HDFS today, one of the really nice things about this is that you can really just snap Paxata in right into that architecture because it was designed to fit in the data lake world. And the last thing I'll mention about technology before we go into some customer use cases is that this was a technology designed to scale elastically. And when you're looking at modern information management solutions and you're looking at either deploying this on the cloud or on your on-premise environments, What you're seeing on-premise with Yarn is that people are able to take advantage of variable workloads. And so on a Yarn cluster, you can have Spark, you can have Storm, you can have MapReduce all running at the same time, and they can take up different and variable amounts of capacity, which matches with the dynamic nature of your business. Well, Paxata was designed for that world. So we have the ability either on your Yarn cluster or in the cloud-based environment to spin up and spin down additional nodes depending on the kind of work you do. So, imagine that you have your classic quarter close process. We've all been through them. And typically you would just buy the biggest honking machine you could find to run these processes. But what you now have the ability to do is to, with virtualization and with these multi-resource environments like Yarn, you have the ability to only use what you need for most of the time. And then when you need to scale up to much larger volumes, you actually have the flexibility to do that in a dynamic way. And then when you're done, you can tear down the extra nodes. And so this importance of having a true elastic architecture that is designed to absorb variable capacity in your business is another really, really important point of how this technology should work in the data lake environment, whether it's on-premise or on the cloud. Now, given everything that we've said so far, and given my nature to speak at 650 miles an hour, but hopefully I'm keeping your attention, the question is, great. So we have a data lake, we have self-service data preparation, or self-service analytics, and we're thinking about self-service data preparation. Does this stuff work? Does it actually add any business value? And can you prove it? So let's go and answer those questions. So I'm going to walk through two quick case studies. One of our customers, one of the largest banks in the world, they're 150 years old, they work in 67 different markets, 84,000 employees, and they have a pretty big problem. And that problem is, over the last 4 years, they have been fined close to $1 billion for a variety of different issues around anti-money laundering. And so they had an initiative to see if Paxata could help them with their anti-money laundering use cases and do it in a way that would significantly reduce the amount of time it took them to do this work. They have thousands of analysts, and they would have 150,000 transactions pending a preliminary review, each one taking about 15 to 30 minutes. So let's see how this use case evolved. So in their case, they have what they call their FCC team, which is the Financial Crimes and Compliance Organization. And that comprises with a few business teams, one for anti-money laundering, one for politically exposed persons, that is, the bank should not be doing business with people who are on the naughty list, and then one for travel and expense fraud. And then there's an entire team, what's called the MI team, who are the business analysts who are preparing the various reports. And then each one of these folks, you can see there are different ratios of the number of people. So there's 70 MI folks, 1,700 Excel power users in their in their end user compute group. And this is their process in their organization today, or before Paxata, I should say. And I bet most of you on this call have a process that looks like this. They have their raw source of data. The business teams put in a ticket. The production support team goes and runs a set of queries or ETL jobs. Then they get a set of Excel extracts. Then the Excel extracts go to one of the hub teams. The hub teams review it and then give it to the MI teams. The MI teams do a bunch of XLS manipulations, and finally they get their reports. Each one of their cycles was taking 25 million rows, and it's increasing by the month. All of this is primarily done using Excel. It is not repeatable. The poor IT team is constantly getting pushed to do more and more extracts. This process took this customer 21 days to run on a regular basis. This was part of a broader data lake initiative. You can see here in their data architecture that they do have a Hadoop infrastructure, and on that Hadoop infrastructure, they have built a set of capabilities where Paxata which is really here acting as the FCC transformer. Again, FCC is Financial Crime and Compliance, was brought in as a layer on top of their data lake environment in order to be able to take the raw data and allow a new community of end users to be able to do this type of FCC reporting and then ultimately push it into MicroStrategy and Tableau. Well, if you want to see what that use case really looks like, you can see that the capabilities in something like Paxata, whether it's automating the split process in a visual and interactive way, concatenating data in a visual and interactive way, using our very powerful clustering and editing capability to look for your duplicates and misspellings. This entire process flow was implemented in Paxata so that they could start with their politically exposed persons watch list, clean up the names, bring in the account information, and look up the transactions. So ultimately, they could tag every transaction that had a possible politically exposed person on top of it, which is a big, big deal for this company. And the results. Before Paxata, 21 days to go through this entire process. Put the power in the hands of the analysts themselves, still governed by IT. This process is now a one-day process. So whether it's politically exposed persons, working with their client list management, or their travel and expense surveillance, they have been able to dramatically reduce the amount of time it takes them to do this work. They've saved a lot of money because they don't have to grow headcount. They don't have to hire a bunch of new data scientists. They can use the Excel skill set they have in their organization, and they are able to save a lot of money in not paying those fines any longer. So this is a great example of a customer who had a data lake environment, had a specific business use case, had analysts who wanted to be deployed to solve this problem, and they were able to dramatically reduce the amount of time it took to do this work. Next case study. We have a customer who wanted to rapidly increase the velocity of their contract-to-cash process in healthcare. They have a huge addressable market with two main lines of business, coordination of benefits and payment integrity. They have 5.5 petabytes of data sitting in their data lake environment. And yet, despite having a very healthy business, their revenue is flat and their expenses were increasing. And the question they ask themselves is why? Well, currently, for this customer, before they started using Paxata, it would take them 300 days, that's almost a year, to onboard a new customer. Now granted, it's a huge volume of data, a lot of people are involved, but a year is a long time. And their CEO himself said they have an intense focus on moving from the sales process to revenue generation as quickly as possible. So they have got to drive that 300 days down. So looking across their multiple lines of business, they were looking for how could they achieve ROI on both their coordination of benefits and payment integrity cases, where they could actually lower the contingency fees for the coordination of benefits and get higher contingency fees for the payment integrity use case. The process that they really care about is what they call ink to green. Ink is when they get a contract signature of a new customer. Green is, of course, when they get paid. So with that 300 days to onboard a customer, why? Why does it take 300 days? And again, a repeated theme that you saw in the previous use case. There are 20 plus handoffs between the business teams and the IT teams throughout the process. So given the amount of handoffs, given the types of tools that they're using, etc., this is a really, really difficult place to be. So they launched an initiative to lower that 300 days to 90 days. Why is that hard? Well, they have $39 billion of paid claim records in that 5.5 terabytes of data. Petabytes of data. They have 1.2 billion eligibility coverage segments, 161 million lives whose data is tracked inside of these systems. I mean, this is a staggering amount of data. And of course, each client that comes in, they don't have the same data. They have different varieties, different sparseness, different data models. Data is missing. And so how was this customer doing this today? Well, they were using the same tools that 99% of the world uses for this type of capability, which is to use Microsoft Excel or Microsoft Access or other manual processes. Unfortunately, that creates a very difficult environment to be able to do this type of work. And I just want to do a quick check to see if everyone is able to see my screen on the webinar. Can I get a confirmation that you are? I just got a note saying that there might have been a problem. Can anyone hear me?
Yep, we can hear you.
Oh, great. I'm sorry. Okay. I just needed confirmation that I wasn't speaking into the ocean. And you're able to still see my slides as well?
Yes.
Okay, great. Thank you. Sorry, everyone. So point being that, let me just go back here. Apologize for that. So because of all the data issues that they had, they were storing all this data in a 26-node Cloudera environment. Well, from there, they have been able to drive down from 300 days to 90 days the ability to be able to onboard customers. They were able to get their business users using Paxata in 1 day because, again, it was designed for analysts. There's no scripting. There's no unfamiliar metaphors that are useful for research projects, but they're not useful for day-to-day end users. When they started using Paxata, they found $147,000 in savings in the first week that they were just prototyping with the solution. They see a 3-month ROI in their current project, and they are well on the path to reducing their ink to green to 90 days. In fact, one of their PI data mapping use case evaluators said, I have been telling everyone who would listen that this is really a game changer for my area, which is awesome. We love hearing that. So net-net, Paxata can not only help them save a significant amount of money, but they can also start moving into revenue generation really, really quickly. If we can reduce that onboarding time from 10 months to 3 months, that's 7 more months of being able to collect fees from each one of their individual customers. So the ROI on this project is already very large, and it's only going to continue to go up. So again, a data lake environment, a specific business use case, bringing it all together in such a way that you can use these self-service information capabilities to make a dramatic impact on your business. So net-net, let's summarize here, and then we'll open it up for anybody who has questions on the webinar. So, the data, hopefully you've seen through this webinar, the data and analytics game has changed significantly. We have moved to a self-service world on the end user side. We've moved to a polystructured data lake world on the data side. And we need a new set of information management approaches that are flexible, fluid, agile, intelligent, elastic for this new architecture. And I gave you some examples of how what we're doing at Paxata is quite interesting in trying to solve some of these problems on the data lake environment and to deliver real successes. And if you're interested in what you heard today, we also have a checklist where you can get it right on our website if you go to paxata.com, and you can download that checklist and actually benchmark that against your current initiatives to figure out, hey, are we really approaching this the right way? Since we're already making the change to a data lake infrastructure, since we already have end users who are moving on this self-service approach, can you tell me what we should be looking for in terms of the information capabilities that people need inside of the new architecture? So with that,
sorry to interrupt. We still see, are you still on slide 29?
No, I'm sorry, I'm not. Is that what it shows on the presentation?
Yes. Do you have the screen paused, or is it playing right now?
No, it shows that it's playing right now. But what I will do is I've asked it to play again. And if not, what we can do, I was actually at my final point anyway. So what we can do is the slides will be available for our customers, of course, and or anybody who's on this webinar. And I'm happy to open it up for questions for anybody who might have questions. And if you can just read out the questions to me if you have them, that would be very helpful.
Okay, perfect. Thank you. We're now going to begin answering questions you guys submitted. So as a reminder, you can still submit questions through the questions pane in your attendee control panel. So feel free to submit those in. We have one question here. So with all the different capabilities you discussed, what's the best way to get started?
Great question. So the first thing I would say is that it's absolutely critical to identify a real business use case on top of the infrastructure you're working on. We have found that customers who have a data lake environment and are looking to begin the process of doing this type of transformation, they struggle if they don't have an identified line of business who they're partnering with a specific business use case that allows them to be able to do this type of work. If they do not have that, then what happens is the project winds up flailing and the customer is not successful. So find a business partner who has a specific need to leverage the investment of the data that's in the data lake and who has an end user community who is really thirsting for information, and start there with a specific concrete high ROI use case like I showed for the banking and the healthcare use cases, and go from there. Any other questions, Andrew?
Yeah, perfect. Let me see here. Yes, so is Paxata an ETL tool or a NoSQL database?
Paxata is neither an ETL tool nor a NoSQL database. ETL tools, as I mentioned earlier, are designed for, traditional ETL tools are designed for relational data. They're designed for a developer community. They primarily work in batch, etc., whereas Paxata is really designed to provide an interactive, visual, large data response time in order to be able to drive to turn raw data into information on demand. However, we do leverage, to answer the NoSQL database part, we do leverage Spark and have built technology on top of Spark to be able to power that interactive large-scale visual experience. But we don't sell it as a NoSQL database per se, but we use technologies from the NoSQL world to deliver this end-to-end information platform.
Okay, let me see if we have any other questions here. Okay, here we go. So for joining large tables, does Paxata use cluster powers, or it has its own engine for the same? How does the table join work?
Okay, great question. So as I mentioned earlier, Paxata does use Spark as the core underlying technology for doing all of the data transformations. And then on top of Spark, we have built a significant number of capabilities that allow us to do this in interactive time. Our engine that's built on top of Spark, it's built into Spark or packaged into Spark, handles all of the joining capabilities by doing it in a columnar manner, whereby we are able to minimize the distribution and the I'm completely blanking on the word right now, but the swashing around of all the data inside of the cluster. So in most of these distributed systems, there is a huge issue with moving large amounts of data around the cluster, shuffling the data, every time that you do an operation. Our technology has been designed to minimize the shuffles by using a set of techniques from the columnar database world that you might have seen in products like Astrodata or Greenplum, etc. And those capabilities allow me to allow the Paxata product to do the joins very quickly and return the results in interactive time. So the joins actually happen inside of Spark on the columnar data structures that we work with.
Okay, perfect. Looks like that's all the questions for now. If we happen to miss a question, we'll follow up directly through email.
Excellent. Well, thank you very much, everyone. And Andrew, any final comments, or should we just close it out?
Yeah. Thank you, and thank you everyone for joining today's webinar. If you have any immediate questions or questions that we weren't able to answer, feel free to email us at info@pexata.com. As a reminder, the recording will be sent to everyone who registered for today's event. On behalf of Pexata and our presenter, thank you for joining us today, and have a great rest of your day.